Now we introduce guided policy search method for robots. First of all, we introduce some basic variables and parameters used in guided policy search method. First one is called controller. A controller means we use this controller to run or operate on a physical robot to generate a demonstration trajectory. That means when a human operate on the robot, when we observe the state, how can we select action to generate a correct trajectory? That means from the initial position, reach the correct destination point. And then we define policy. This policy means we need to use reinforcement learning to learn. That means we want to learn to select a policy. When we see the similar state, we can generate similar action. That means to get optimal trajectory. That's our goal. So for our system, we need to define because the robot is in a dynamic environment. That means we use policy just to select action. And how can we get the real next state depend on the system model or dynamic. Now we suppose dynamic is known. That means this also is a state transition probability. That means from state SAT to SAT plus 1 based on action AT. And how can we evaluate the policy we select is optimal? We use objective function. This this expectation loss, and this loss is along the trajectory tau, as is one absolute, not just one step. And under this, the policy we learned, we want to compare the controller generated trajectory and the policy we learned generated the trajectory. We need to compare trajectory, make sure they have a minimum. We have minimum expectation loss. Then we get optimal policy. Use this policy, we can in a different dynamic environment can generate a good policy. So these are to get generate the correct trajectory. That means from the initial point to the terminal point. So we use the reinforcement learning to minimize the expectation loss. That means we define this objective function and with this constraint condition, and then we try to find the optimal position or optimal policy. Let's see how can we understand the guided policy search method. Based on the reinforcement learning, we know that from one initial state we select policy. Then based on this current state, how can we select the action? And then if this P, this state transaction probability is known Oh, okay, and we know how much reward we get, and then we select, the policy means we select the optimal action to get the maximum reward until, step by step, until we reach the terminal state. We see what's the state value defined in, in this state, or we have action state value function at this state. Now we go back to the robot problem. That means, for example, we human run a real robot system. We from this state, we know how can we select the action based on the knowing system dynamic. We have, reach this next state step by step until we get the correct, the terminal point. Reinforcement learning, try to find a policy to understand people, how human being or robot, real robot, how can, see this situation, this state, decide which action select which action for the correct, trajectory. Here we just, we use reinforcement learning, try to understand and how can we, learn a policy, use this policy, depend on what robot, see the current environment, how can select the action, generate, based on the knowing system dynamic, reach the next state, and step by step the same thing until we get reach the terminal point, and we generate a trajectory. And right now, guided policy search methods is we use this human algorithm, or robot generate trajectory, and we try to learn a policy generate another trajectory. We compare trajectory, we get to define the objective function and make their expectation loss is a minimum. That's our goal. And how can we get, select the policy? Right now, of course, the popular method is use policy network. Then new network, we can handle, the high dimensional action space, or even continuous space action space. For example, here is we got from robot camera, we got RGB image, we use as an input, then we can select, action. Use this action, then we get a policy, use this policy, and we based on, initial, for example, initial state we generate, for example, right now we know what's the state transaction probability. Based on this policy, we know, what's the next state. And so on, we generate a trajectory. And also, I mentioned that we use the controller algorithm, the real physical robot that we generate a trajectory. Right now, because we know the system dynamic, so we know exactly, what's the next point when we, run the real robot. And then we compare two trajectory. Of course, we use this S1 too, just this, trajectory generated by the controller as the guided trajectory. And then we step by step, we optimize the this policy network. Finally, we get converted objective function. Then we reach the optimal policy. For more information, we can get from this references. Thank you. Bye.